Hi everyone, and welcome to Pre-Calculus Lessons 9.1 and 9.4, Vectors in 2 and 3 Dimensions. I decided to combine these two lessons because they're very similar. It's just that one of them is working in 2 dimensions, x and y, and the other one is working in 3 dimensions, x, y, and z. But many of the calculations and many of the facts are still exactly the same. So let's start off by asking, what is a vector? Now, if you watch that video clip that I posted, you had the character vector explaining what a vector is. But let's take a look at the technical definition. A vector is technically a directed quantity, a quantity that involves both magnitude and direction. Okay, so it generally is going to look like a line segment or a ray. Usually we do put an arrow on it, so it's a ray that has an assigned direction. That's why the arrow is there, because it shows the direction of that ray. Now, if I wanted to name the vector, I could name it as vector AB, or in my case over here, vector CD. And notice that this is almost like the ray symbol from geometry. It almost looks like it, except that it doesn't have a full arrow at the end, and that's the vector symbol. So that notes that this is a vector known as vector AB or vector CD. Now, every vector has an initial point or a starting point and a terminal point or an ending point. Okay, and the arrow of the vector always points in the direction of that terminal point. Okay, so there are a few other basic things to know about vectors. A unit vector is a vector of length 1. So that means if a vector is 1 unit long, then we would call it a unit vector. And we have several unit vectors that we use to describe other vectors. The 0 vector basically has a length of 0. It's essentially just a point. So the initial point and the terminal point are going to be exactly the same. Now, equal vectors are vectors that have equal magnitudes and the same direction. Basically, if you count the rise and the run on the vector, and you make sure that they're pointing in the same direction, then you would know that those two vectors are equal. You can also double check their component forms. Those will be equal, and we're going to talk about component form next, so you'll find out what that is. So component form is a method of naming vectors that lists the horizontal and vertical change from the initial point to the terminal point. And it's listed almost as an ordered pair, but notice these are not parentheses. They have little points at the ends. So they kind of look like arrows. Okay, and that's what notes that it's not an ordered pair, but it is a component form. Okay, so if you wanted to find the component form for a given vector, you can count it on a graph. And remember, it's the horizontal change and then the vertical change. And you just start counting at the initial point, and you count the horizontal first. So this one goes 2 over and then 3 up. So it's the horizontal component, which is 2, comma, the vertical component, which is 3. Now, if you were to go down or left, you would make the number negative. If you don't have a graph, you can simply subtract the terminal ordered pair minus the initial ordered pair. And when you do that, you would do the x values subtracted and then the y values subtracted. Okay, and that would give you an xy pair at the end. One component form can represent many different vectors, and that's why we can have equal vectors. So this component form could represent a vector that doesn't start here. It could start over here in my picture. Okay, so that component form can represent many different vectors that have different initial points, but they could still have the same exact component form. Let's take a look at some examples where we have to deal with component form. As we go through these examples, I highly recommend trying the example as you're watching the video. So once I read the example question, pause the video, try to do it, and then press play to see if you're right. I'm not going to say that every time, but I highly recommend it because that's what we do in class. I explain how to do something and I say, okay, now try it. And it helps you to learn it better. It helps you to identify any questions you have. And as an added bonus, it makes the video less boring. So I highly recommend doing that. In this example, we need to find the component form of vector u with initial point -2, 5 and terminal point 3, 7. Now, I didn't graph this, so I would recommend doing subtraction to find the answer. But if you'd prefer, you can graph it and just count out the horizontal component and vertical component. So try and do it, and then press play to see if you're right. So for the horizontal component, I took the two x values, the 3 and the -2, and I just subtracted them. 3 minus -2 equals 5. And the order is important. It has to be the terminal point value minus the initial point value. For the vertical component, I did the terminal point y minus the initial point y. So 7 minus 5 is 2. And then I just wrote them as the x value, comma the y value. And I put it in these unique brackets, okay, to note that it is a component form. Let's look at another example. In this example, I've given you three-dimensional points. So you have an x component, a y component, and a z component. But the process is still the same. So you need to find the components of the vector with the initial point p, 1, -4, 5, and terminal point q, 3, 1, -1. So you're doing the same process, terminal minus initial. So see if you can do that, and then press play to see if you're right. So what I did is I did the x values subtracted, terminal minus initial, the y values subtracted, terminal minus initial, and the z values subtracted, terminal minus initial. And the result of all those subtractions was the component form 2, 5, -6. Let's look at another example. In this example, we're given the vector v, which is 3, 7, and that's the component form. And it's sketched with an initial point 2, 4, and they want us to find the terminal point. So what we're going to do is we're going to create equations from this. Remember, it's terminal minus initial equals the component form. Okay, so put variables in for the terminal points x and y, and create equations and solve them to see if you can find that point. So pause the video, see if you can do it, and then press play to see if you're right. To find my horizontal component, I did the terminal point x minus the initial point x equals the component form x value. So all I had to do in this equation was add 2 on both sides to get x equals 5. For the vertical component, I took the terminal point y minus the initial point y equals the component y value. So I added 4 on both sides to get y equals 11. So my terminal point has an x value of 5 and a y value of 11. And here's my ordered pair. Let's look at another example. So this is a three-dimensional example that works in the same exact way as the previous example. They've given us the vector b with component form -2, 1, 3, and it has initial point 2, 1, -1, and we need to find the terminal point. So see if you can follow the same steps that we did last time and find that terminal point. So I created the equations. Terminal point x minus initial point x equals the horizontal component of our vector, and I just added 2 on both sides to get x equals 0. I did the terminal point y minus the initial point y equals the component form, and y was 2 when I added 1 on both sides. I did the terminal point z minus the initial point z equals the component form z. I subtracted 1 on both sides, or I added -1 on both sides to get z is 2. So my ordered pair was 0, 2, 2. And that's my terminal point. Let's look at another example. In this example, we need to sketch the representations of the vector w with component form 2, 3 that has several different initial points, 0, 0, 2, 2, -2, -1, and 1, 4. So what we're doing is we're actually sketching 4 equal vectors, and they just have different initial points. So start by graphing an initial point, and then count 2 units over and 3 units up, put a terminal point, and draw the vector arrow. And do that for each of these points. So try and do that, and then press play to see if you're right. So what I did is I started at 0, 0, and I went 2 over and 3 up, and I drew an arrow to this point. Then I started at 2, 2, and I went 2 over and 3 up, and drew an arrow to this point. Then I started at -2, -1. I went 2 over and 3 up and drew an arrow. And finally, I went to the point 1, 4. I went 2 over and 3 up and drew my vector arrow. So that's it for these examples. We're done talking about component form, but now we're going to talk about operations with vectors. Okay, there are 3 operations that we talk about initially. The first one is adding, and I like to use what we call the numerical method, where you simply add the component forms. You add the x components and you add the y components, and if you're working in 3 dimensions, you would add the z components. Okay, so you simply add them. Subtracting would work the same exact way. You simply subtract the component forms of the vectors. And finally, multiplying by a scalar. Now, a scalar is a quantity that's represented by one value. So it's like 3 or 6 or 4 feet. So you just are scaling it up or scaling it down. And basically, you just distribute it into the component form. So that's going to stretch or shrink your vector. Now, I should note that there are 2 other methods of adding. You can use what we call head to tail method, or you can use the parallelogram method. Now, those require some graphing, and we're going to do it a little bit in some of our application questions, but if you have to add vectors, I highly recommend the numerical method. So that's what we're going to be doing for now. Let's take a look at an example. In this example, they've given us vector u, which is 2, -3, and vector v, which is -1, 2. And those are the component forms. They want you to find u plus v, u minus v, 2 times u, -3 times v, and 2 times u plus 3v. So pause the video, see if you can find all of those, and then press play to see if your answers are right. For u plus v, all I did was I added the x components and the y components, and I got the component form 1, -1, and that's the resulting vector. For u minus v, I just subtracted the x components and the y components, and I got the component form 3, -5. For 2 times u, I simply multiplied both the x component and the y component by 2. I got 4, -6. For -3 times v, I took my v vector and multiplied both the x and the y components by -3 to get 3, -6. Now for the last one, 2u plus 3v, I highly recommend writing down what 2 times u is and writing down what 3 times v is, and then doing the addition. Because if you try to do it all in your head, generally you're going to confuse 1 or 2 of these numbers, and you're going to get a wrong answer. So 2 times u ended up being 4, -6, and 3 times v is -3, 6. And I just added them together to get the component form 1, 0. Okay, we have one more example left in this video. Let's take a look at it. Okay, they've given us vector u with component form 1, -2, 4, and vector v with component form 6, -1, 1. And they want us to find u plus v, u minus v, and 5u minus 3v. So this is going to work exactly like the previous example, except that we have x, y, and z components instead of just x and y. So pause the video, try and do it, and then press play to see if you're right. For u plus v, I got the component form 7, -3, 5. U minus v, I got -5, -1, 3. And for 5u minus 3v, I got -13, -7, 17. So let me know if you have any questions, and don't forget to watch the next video.